Hello everyone, welcome back again to a different chapter. We are still in module 1. So in this chapter we are going to talk about database system concepts and architecture. So in this chapter we are going to see data models, their categories, database schema, instance and database state. We will see 3 schema architecture and data independence, DBMS language and interface, and database client server architecture. In client server architecture we will see different type of architecture of database. Let's first see data models. So as we know that when we have a set of related data or mini world, we can actually model them using a data model. All right, a data model means a set of concept by which we want to describe the structure of database, the operations for manipulating the data, and the constraints of the data should follow. So a data model, when we'll model a set of related information, we are going to model using a data model. But each data model should have these 3 components. This data model should have the structure of database, means how the data will be structured. Each data model should also describe the operations for manipulating the data. And constraints means actually a set of rules. All right, constraints means a set of rules or restriction that will be forced on the set of data. So the data model will provide the proper means to describe the database design at physical level, logical level, or implementation level. The data model constructs will define the database structure. All right, and these data model constructs will include data element and their data type. For example, let's see when we are talking about so we may talk about student and course, this type of information. So how we are going to model them, we have to store their data elements and their data types. So for example, when we are going to store the information of student, so each student have their associated attribute. For example, name will be of string type, all right, or character varchar type. Actually in database we say we tell them there are some specific types also in the database programming, and say student number will be integer type or number type. All right, grade will be say also number type. All right, so in the data model we are going to store the data elements and their data types. So in the data model we group the related type of information, related elements into one entity. For example, when we have a list of students, all right, say list of students, say Smith, Jack, and all their information, we actually group them together and we make them one type of entity. Okay, we group them together and we make them one type of entity, so that actually the it gives us a way to make our database self-describing. So each of the related information or each of the related record, they are known as record or tuple. Okay, and also the relationship among entities, we can have different type of entities. For example, this is a entity of student type, and we can have entity of course type, where we are going to store all the same type of information, means all the only course record we are going to store it here. All right, and the data model is going to also show us the relationship among entities. Constant means constant will specify the restriction on the stored data. All right, so using the constraint will help us to make the data more consistent and valid. Okay, if the data satisfy all the constants, it will be known as valid data. So it's important that in the database all the data should have to follow the constraint. Okay, so it will be important whenever we are going to modify the data, manipulate data. For example, we want to insert a new data or update a new records. It's important that each of the updated record has to also maintain the constant that are specified on each of the stored data. All right. So in the data model, it will also specify the data model operations. Those operations will be used for specifying database retrieval and manipulation by referring to the construct of the data model. The basic operation, the operations on the data model, it could be of two types: basic model operation and user defined operation. Basic model operations are actually simple operations, like if we want to insert a new record, delete a record, or update a record. And there could be different type of operation known as user defined operation. So user defined operation, we cannot just write a simple query and we cannot make an operation. User defined operation can be a combination of multiple transactions. Okay, for example, say I want to compute a student GPA. Okay, so there may not be a single query I will be able to compute the GPA. I may require a multiple query, multiple transaction for that. So in that case, actually, I may have to write a program. All right, write a program, database program, also known as like SQL procedure. All right, like writing a function using SQL programming to do that. All right, then update inventory, something like that, where we can actually give the operation a user defined name. All right, the data models could be categorized into three types: conceptual, physical, and implementation. Conceptual data model give us a concept that are very close to the way many user will perceive the data. The conceptual actually give us a data model in a very high level or semantic level. High level means the way actually we user visualize the data. In that level, the data model will be the data model will be provided. So example of conceptual data model is one example is known as ER model or also EER model. ER model stands for entity relationship model. ER model stands for enhanced entity relationship model. So in this entity relationship model, actually the data model will be represented using a set of entities and the relationship between them. All right. So those model, they are actually in very high level or semantic level. Actually, they will not represent the how the data will be stored and the very implementation detail. Okay, in this model, the data will be represented as a high level, means how actually the user is going to visualize the data. In the physical data model, it will provide a concept that will describe the detail how the data is really stored in the computer. All right. So these will be actually specified in ad hoc manner using the DBMS design and administration manual. So it will provide us actually in very low level how actually we are going to store the data, okay, in the DBMS system. The implementation data model actually falls in between the conceptual and physical model. The conceptual give us very high level data model description, and the physical data model give us in very low level how actually the data models are stored in the database. And implementation data model falls in between them. So in many commercial DBMS implementation may use this implementation data model. So let's say DB database schema and database state. So database schema means the description of the database. So the database schema will give us a well-viewed description of the database. The database schema will include the description of the database structure, the relationship, data type, and their constant. As we said earlier, that data model means actually data model includes the database structure, database structure, their operation, and the constants on the database. The database schema will give us a clear description of the database where it will give us the where it will include all the information about the database structure, the relationship between entities and data types, and the constant. So a schema diagram means a illustrative display. We know what a diagram is. A diagram means actually where we use some graphical image, some symbol to show a visualization or illustrative display of something. So when we are going to see an illustrative display like a diagram to show the database schema, it's known as a schema diagram. All right, and a schema construct is a component of the schema or an object within the schema. So a schema construct means all the component of the schema. Okay, so all the component, we are going to see an example that a schema has some database structure, database component, their relationship, and constant. So some component could be student, course, their name, like that. So let's see an example. This is an example of database schema or database schema, and the way we are showing the database schema is known as schema diagram. So this thing is the schema diagram of a database. So we are using the same example where you are using a university database that we saw actually in our last chapter, university database, where we have student, course, prerequisite, section, and grade report. So this database schema actually give us a description of the database. So this schema is saying that we are storing the information of student. Each student has these following attributes: name, student number, class, major. All right, and they will also say the data types of each attribute. For example, we can visualize name means name, so it will be string type. Student number, numeric type. Class could be a numeric type like class 1 to B, 1 2 3. Major could be a string type, for example CSE, electrical, like that. The database has course information, and each course has this following attribute. This database has prerequisite, section, and grade report information. So by seeing that, this schema give us a database description of the data. And this is the schema diagram, means actually this is actually a formal way to show a database schema. All right, so using the student we are going to group all the information of the student, all the same type of record, student record, we are going to store using the student entity. Okay, so they are also known as like entity or relation. Okay, all right, so we'll talk about the name, the formal terms in later chapter. Okay, but for now just say that we are using a entity type like student type to store all the student information. Now using this schema diagram, we are going to actually showing how a database schema look like. So the name of the entity, and then we are going to use like a table only with one row where we are going to only show the column header, means the name of the attribute. Say here name, we have the number, student number, class, major. Okay, so this is the way we can show the entity and the data types. So this is an example of schema diagram and database schema. So database state. Um, Database schema give us the description of the database, means what a database is going to look like, what are the entities and what are the attributes of the entities. Database state is the actual data stored in the database at a particular time or particular moment. Also database state known as a snapshot of the data. Okay, means actually when we have a data and we have a collection of, when we have a database and a collection of data stored in the database, this is known as a database state, also known as a database instance. For example, let's look at this database state. We have here couple of student information, couple of course information, okay, couple of course record, couple of section record, some records for grade reports, some records for prerequisite. So actual data are stored in the database. So a database state means when we have a collection of data stored in the database. So at a particular time, at a particular moment, this is a database instance. Okay, so the database state actually can change whenever we are going to insert a new record. The database state will change. This will be a different state of database. Okay, but at a particular moment with a collection of data is known as a one instance of data or database state. So the database state refers to the content of the database at a particular moment with a set of data. So initial database state means when you have just, let's see, when you have created few tables and you have some initially loaded data. Okay, so that's your initial database state. Say you have some initial data, initial record, you created your all the tables and initially you loaded some records, say from the file or some other method. All right, so that will be your initial database state. Now the database state will change whenever there will be any update in the database. For example, you inserted a new record, you update a record, or you deleted a record. All right, so database state will change after any kind of manipulation or any kind of update in the database. The valid state means that we can say a database is in valid state if that state satisfies the structure and constants of the database. So the constants are means, constant means the some rules and regulations on the data. So whenever we want to insert or want to do any kind of update in the database, we have to make sure that those update has to follow the constraints of the database. In that case, we can say that the database is in the valid state. So the difference between database schema and database state is that database schema just give us the idea, the description of the database, means how many tables or how many entities there will be, what are the attributes of the entities. Okay, but the database state means actually real with the database with populated data. So the database schema doesn't actually change very frequently. It changes very infrequently. The idea is that when we have a real software or application, depending on the application, we create a database schema. All right. Now, database state means we insert some initially loaded database, or whenever we update the database, it creates a new state of database. The database state can changes every time the database is updated. All right. So the schema is known as intention and the state is known as extension.